thanks for coming by. I'm really impressed. So many people. That's amazing. That's really amazing. Isn't it great to meet people again after that long time? I mean, shaking hands. I mean, it's really good to be back on a show like this, I think. So, our talk today is about color consistency from lens basically to the living room. And I wanted to take this a little bit from a different angle, because normally when people talk about calibration, it's kind of everybody falls asleep, right? Because it's like, oh, calibration, really? And is that so important? Yeah, it's actually very important. And how important it is, I want to show you in this talk. If this thing works. Oh, here we go. So, Portrait Displays works with ASUS for a very long time on a lot of products, on the monitor side, on the laptop side, on the projection side, when it comes to either certification of products for color accuracy or calibration of specific displays, so that you can trust your display and that you know what you're actually doing, right? And so I want to talk a little bit about how our Calman solutions, Calman calibration software that we manufacture and that we produce, work together with the hardware of ASUS, and also how that DNA in those different products actually help you to get color accuracy across the entire workflow and make sure that you have creative intent being maintained up to the point to presentation. So that's a very important aspect, right?
Swapping to this one.
Okay. Is that better? Oh yeah, okay, there you go. This clicker here somehow is funny. Oh, here we go. So maybe 2 minutes about who we are. So Portrait Displays is driven by color backed by science. Means we have an R&D department with a lot of color scientists working on different solutions, hardware-wise, software-wise. What you can see is we do software for displays mainly, right? And it's all about color and display control. So we can control the calibration process. We can load 1D LUTs, 3D LUTs into the displays. We can have color controls of the scalars that are in the displays. And it's actually cross-platform. So all the solutions are somehow Mac-based, Windows-based, iOS-based for mobile devices. Because as you see, more and more mobile devices, for example, also being used in production. So it's very important that we actually make sure that we have consistency all over the place. We have a lot of different offices, including Asia, where we had just opened our Taiwan branch office. So to be very close with our partners like ASUS and making sure that our R&D works very efficiently with ASUS R&D. This thing doesn't like me. Oh, here we go. So what we do on the display side, for example, is we work with all the different manufacturers that manufacture TVs, monitors, laptop computers, right? All in ones, pretty much everything that ASUS is doing, now including this big great micro LED screen. We are also in the chip design, which means we work with MediaTek, for example, which is reference chip design, so you get all that calibration capabilities on a chip, for example. That's getting more and more important, so you can control color in consumer products or in professional products. And of course, we have a lot of different color solutions. The biggest one is Calman calibration software. I'm going to talk about this more in detail. And so from the areas where we work as Portrait Displays is the commercial section, for example, Pro AV very much, like video walls, education, medical imaging. So it's not all about visual arts and entertainment, although I talk about visual arts and entertainment today, which is still one of our core businesses. And that goes down to the consumers. So for example, in the retail environment, retailers are using the same software to calibrate the TVs for the homes. So when you create content and you want to make sure that the content looks correct, you also hope that it's looking good in the homes, right? Because you're creating, in the end, you're creating stories for the audience, right? So all of this is somehow kind of maintained from lens to the living room. You know, that's why we call it like this. We have a lot of studio collaborations. So we work with Lucasfilm, Marvel, Netflix, just to name a few, and they all use Calman in their production workflows, making sure that all the monitors they use from set to post to in contribution, VFX, everything works right and looks correct. And the important part here is that we help them also then to maintain that up to the consumers. And then, of course, on the industry affiliation side, we are part of the Society of Motion Pictures Television Engineering group. In the OSVP, we do a lot of on-set virtual production research right now, especially with SMPTE and some of the engineers. And our color scientists are pretty much involved in this because there's a lot of color issues to run into. You have cameras, you have LED walls, you have video village, on-set monitors, camera monitors. How do you make sure that that all matches, right? I mean, there's a lot of stuff, and a lot of things where we still do a lot of research and where we're involved in that as well. And as a member of the UHD Alliance, that's more on the consumer end, we are also helping to design specific parameters like filmmaker mode, thinking about how can you improve this, how can you calibrate TVs for the consumer side. There's also a lot of stuff that we're doing. So our experience goes from production to retail and to the homes, right? But that's what I want to show you. Today I want to show you why it is important that you get all your displays right. Because color is a tool for storytelling. And before I really start to talk about calibration, I first want to talk about the art. Because that's actually what you do. You create art. And when you create something, you want to make sure that people are going to see it the way you hoped it's going to look like. Because you have a vision, and you want to maintain that vision and get that vision across, right? And so there are three different important things you want to think about if you start to create your vision. One is mise en scène, that's a French word for how you would design the scene. I mean, everything that's somehow related to how your shot is going to be designed, right? You have cameras, and those cameras have their own characteristics, like a camera gamut, its own color signs, everything that's somehow part of that piece of the equation. And you have the monitoring. So that means you have actually three different components. And your art director is the one that picks the nice cloth, the fabrics, the light, everything. And you want to make it sure that it looks exactly how you hope because it fits into your story. But then there's a camera and a monitor involved, and hopefully it somehow works out, right? So let's look at mise en scène first. So it's actually coming from the theatrical world, right? How do we design the stage? What's the stage lighting? What's the blocking? What is the production design? What are the props? How do the props look like? And what's the color on the set? All the different colors, the carpet, the sofa, the fabric, the clothing. What do the actors wear? What's the lighting? Is there neon light? Is there incandescent light? What is the lighting? Is there LED lighting? Whatever you do you change like John Wick, have crazy colors on set? All of this normally is taking into account when you do a proper planning, right? So that a scene like this is not coming together by coincidence, right? So there's a lot of work and thought of process to get the scene actually the way it looks like. The colors are matched, everything is perfectly aligned. That's what we talk about when we're talking about mise en scene, for example, right? But it's not just movies, it's the prop design, everything, the lighting design, everything that makes up the scene that's part of your story you're telling, right? But it could be also documentaries. It doesn't have to be a movie or a TV show. It can be everything you create. Everything you put your own thoughts into, how you want to have things look like, is what's part of your story. Now, the production design is pretty much involved in this. And so in the early stage of your, I have to be careful here with this chair. In the early days, in the pre-production and the planning phase and the planning stage, that's what your production designers actually do. They put everything together on paper. You have your meetings, you define how the look is, and all of this needs to be put together as part of your visual experience. And then you have the technical department that's coming in very early, like the DP, for example, meeting with the director and starting to figure out what the right camera might be. Thank you very much. What the right camera might be, right? And what the look development is for the show, right? So there's a lot of camera testing because every camera somehow has its own look. So it has a camera gamut, which is all different because all the cameras have somehow a different characteristics, right? Also the format you're deciding to shoot on, what you can do with this format. What color space you can actually capture with your camera. So your capturing device is already defining what kind of colors you actually can capture. That's very important, right? There's this very nice story about NBC a lot of years ago, like in the early 80s or something, when they had this nice TV show and they had all those neon lights and the production designers came in and had all those fancy lights, everything beautiful. But then actually on camera, it didn't show up at all. You know, in the homes, people didn't see it. Why? Because the video system wasn't ready for this. It was good for the audience in the studio, but these were the only people that actually saw how much effort was put from the production design into the set design, right? So you want to think about this in the first place. Now, interestingly, you're already using monitors to judge what you see. So it's already there where you start and where you should think about what your displays are doing. Because you're making very important decisions in the early stage before you even go into production, right? The other stuff, of course, is dynamic range and all those kind of things, you know, how much stops and What do you want to preserve, and is it going to be for HDR, is it going to be for SDR only, and all those kind of things, right? And then it's, of course, the color palette. So it's kind of the look. So you probably have your colorist, and your colorist ideally is going to start working with you in the early stage of the production. In the high-end productions, normally you have that. The senior colorist or someone is being involved very early in the early stage of the project, making sure that you already define the specific look of the movie or the show or whatever you're going to do. And so that becomes already part of the planning. And all of this is basically judged already on monitors. You even sit together normally and have a session where your DP puts up kind of a couple of movies, couple of TV shows, and you show, as a director, you show your DP what you think, what you would like to have, which direction you want to go. You probably reference a few things. So you already look at that ideally on a very well-designed system so that everybody understands, oh, this is the direction we actually want to go, right? And then you create the look design, you make sure that this is somehow defined so that in production, on set, you might have a DIT that can load a couple of LUTs, creative LUTs, so that you can already, on your on-set monitor, you can have a look, at the director's monitor can have a look, oh yeah, that's somehow it's going to look like. And then later on, you carry this on in post, and then the senior colorist is then continuing with this and working on this in post, and finishing it and make the final finish, right? So, in other words, there's a lot of different monitoring that's happening in the entire production workflow. And it starts very early already in pre-production, before even acquisition. And then in the acquisition process, you are looking at monitors, right? Be it a DIT card where you have an on-set monitor, a village, right? It continues contribution in post, color correction, grading, all those kind of areas, right? Editing, whatever, final grading. And then it's finishing and delivering, and you're also going to have hopefully QC, that someone with a very well-designed system is looking at the final product and it says, yeah, that looks good. That's exactly what we were thinking. And they're just starting to figure out, okay, that's what we want to do. Oh no, that looks funny, what happened here, right? So we probably want to go back and check back what the source material was about or what the shot looked funny. So all of this is somehow a very important part, right? And then in the end, you have the deliverables that are going to be provided. Now Netflix, for example, requires reports because Netflix preferred vendors normally have to show that their hardware is calibrated on a regular basis. So there's actually a very high level of production control depending on the partners you're working with. Because they understand that if your monitors were screwed up and you were just correcting color to only God knows what you were doing, you know, it could be very funny then in the end on a very well-designed TV or something that's running in a calibrated mode or whatever, right? So you would want to ask, why do I then need to calibrate? Are the displays not perfect when they come out of the box? No, they're not. I mean, it's pretty simple. No, they don't. So I'm here just to tell you, no, you still need to make sure that you know what you're doing. The displays are very good when they come out of the box. They have very well good calibrated, pre-calibrated modes that normally should meet all the standards, yes. But there's still a manufacturing process. Panels are all different. You have deviation in the manufacturing process, in the factory process. There's a lot of stuff that could go wrong. So you need to check. You never should trust. Even a $30,000 reference monitor, I don't trust. I just don't trust. I measure. And then I look at this thing and I say, yeah, that looks right. After I measured it and I have some reference content, I say, that looks right. Right. So there are a lot of things that actually can go wrong. And in the calibration process, what we normally do is we actually have a reference and we're comparing the reference with what the display is doing. Now, how are we going to do this? Well, we need a meter. This is this kind of probe in the center you see on the screen, and that takes the readings off the screen. So we have a software, in this case, that's what we do, our Calman software, that's controlling the meter, and it's also controlling a pattern generator. So we're not actually pulling up our favorite movie, like a DVD or a Blu-ray, to say, oh yeah, that display looks right or not. All the latest pictures I took on vacation, that doesn't work. So what I need is a reference pattern. And those reference test patterns are designed on the fly, rendered by a pattern generator. And that pattern generator can be anything. We can do this with software, we can do this with hardware. That should not be part of this talk today. But we have a reference that we can compare to that's very important, right? So what we do in the calibration process, we take a reading of a specific test pattern, and then we're comparing that reading with the target. So every reference pattern basically is our target, and we basically compare this and see how far are we actually away from what the display actually should display. And that's what we call the delta or the offset. And human vision is nonlinear. There are specific colors we're much easier going with our eyes, and others we're very critical, depending on what you actually see. And so a color calibration software is designed to take that into account. So that means we have a way on a scale to define how big is this error. Is this an error we can ignore? Because you won't see the difference between the target and what the display is doing, or the reference and what the display is doing. Or is it an error that's too big, so you have to do something about it? So you have to fix it, right? And so that's what it's done. So after calibration, hopefully, and it's called, the typical scale that is used is called the delta E scale. So that's where you see, you basically have those different bars. So every bar here represents one measuring point, right, in the color checker. That's, by the way, kind of a standardized I would say, validation methodology to define how well this display is performing. And you normally want to be below 2 on the scale. When you're below 2, that is something where the typical observer, I mean a non-trained person, starts not to see any big difference anymore between the reference color and the color that's actually displayed. There are people that see it, like with a golden eye, like colorists, very trained people. You want to make sure that you have a much lower delta, by the way. So with a reference display, you normally want to have a delta of 0.5 or something. So like a reference display should be calibrated to a point that's almost have no visible color error. That goes up to 0 almost. And that's also the difference between a reference monitor and a non-reference monitor. So if you are on set, you probably don't have to have reference monitors all over the place because it's pretty expensive if you would run this. And it doesn't make sense, right? So you want to have a camera monitor, you have an on-set monitor, director's monitor, but then your reference monitor should be really the best as it can be because you're making your color decisions, and the colorist you're working with is making all of that color decisions as part of your storytelling process. Everything you do is going to be defined on that device. So reference display is a measurement device. It's not just a screen. And that's why it's very important that this is also fixed. The other ones should match, but they should not have to be as precise as your reference display. So moving on, what could go wrong? Well, I mean, there's a lot of stuff, right? Why you should actually calibrate. The first one, of course, is color consistency in the entire production workflow. So, because let's say you have a scene, it was already shot, it was pre-graded on set, and you already have a look on the monitor that has a creative LUT on top of what you see, and you want to make sure that everybody sees the same thing. So it's hopefully that all the monitors on that way or in this workflow are calibrated in the same way. So everybody is going to see the same stuff. Not someone in VFX suddenly has a plus blue picture, or the editor is looking at a totally screwed up monitor and is kind of going crazy because it looks all funny. So you want to make sure that you have consistency. And there are a lot of reasons why those displays could be wrong, right? I mean, there's a lot of display dependent rendering attributes, right? It's the display technology. Every technology is different. You have OLED, LCD, quantum dot based LED technology, whatever. You have a lot of different panel types. They have different gamut capabilities, so the color gamut might be different. So higher saturated colors, lower saturated colors. You have different luminances. So you have light output that can go up to 4,000 nits, like the reference HDR monitors, or like a Pulsar, which is not commercially available if you work with Dolby. So they have those kind of super high brightness displays for HDR, Dolby Vision mastering, or Dolby Cinema mastering, or everything else in between, starting somewhere at 1,000 nits and going up to 4,000 nits. And then you also have a lot of different production standards. So depending on what your target is, depending on what you're mastering your content for. So it could be HD TV, which is 709 color. It's a totally different color gamut than, for example, P3 for digital cinema, or P3 color that is also being utilized for UHD Blu-ray, like P3 D65 with HDR. So it's a totally different color gamut. Or BT 2020, which is the biggest color gamut. So there are a lot of different standards as well. So it's not just the display, it's also the standards you want to meet. And depending on where your content is going, you have to master and you have to grade different versions of that content. So you ideally have a 709 mode in your monitor that's calibrated to 709 D65. You also have a P3 D65 mode that's hopefully calibrated to it. And you have a BT 2020 mode that actually is doing this. So I think you get the concept. And there's a lot of stuff you want to make sure that it's right, because otherwise you don't know what you're doing. And then of course there's a lot of potential stuff that could go wrong, like there are technical issues with the monitor. You just don't know, because maybe it worked fine yesterday, and then the next day in the next grading session, you probably, you didn't check it, and you look at this like, whoa, that's funny. What happened, right? Wrong display settings. A lot of times people are just playing around with monitors. You see that a lot, especially in production. I mean, on set. People are cranking up the brightness, cranking up the contrast, cranking up everything just to get a bright image. But actually they're changing the signal. So what the camera sees and what you see on the monitor when it comes in with SDI is totally screwed up. You have clipping or whatever, because people are just thinking, oh yeah, we have to make it brighter, but actually you see totally wrong images. So just as an example, I mean, there's a lot of stuff we could go on. And then there's aging. Aging means over time the display is changing. That is especially hard with all that's somehow HDR related, because with HDR, the panels are driven so hard to get the highlight up you need for the HDR mastering. And then on top of this, let's say you do the grading session, you normally put your content on pause, because you're grading on a still frame. You're not grading while the content is moving. So you basically have a constant light output. And that means you have to make sure that over time, your display is not changing. Maybe you also want to correct this after a while, making sure that's still running, right? So, and there are a lot of kind of technical parts, like linearity issues. So red, green, blue, the color channels, they actually should be linearized so that you have a correct grayscale RAM, that you have a correct whatever luminance dynamic range it's correctly shown on it's showing display. Don't have any clipping, you actually should see every detail in the signal, because the signal is the reference. The display is not the reference, the signal is the reference. So you match everything basically to that reference. This is something that could be changed and altered, right? You could have a gamma correction issues, right? So that your OTF is looking wrong. The PQ curve that you have for HDR might be not ideal. You probably could have clipping in the blacks, you have crushed blacks, or one of the most typical reasons something is screwed up is because you basically mixing up full range with limited range video. A lot of times, believe it or not, there's a lot of stuff that people suddenly are on full range, the math is wrong or whatever, and suddenly you have wrong values actually showing up on the screen. You want to fix all of those kind of things, right? Color gamut, what I already mentioned. And so mappings. That means that all those different colors that actually should be displayed correctly in a specific video standard should be right? And then there are conversion issues. Sometimes people have conversion somewhere going on, and that is actually not just a display thing. It could happen somewhere even in your chain. That's another issue. So you have a calibrated display. This thing works absolutely right, but something else in your chain screws up your picture. So how are you making sure that you know where that source of error is actually happening? Is it the playout? Is it the distribution? Is it the converters? What is it, right? So that's also a reason why you want to check what your display is doing, because when you know that your display is right, you can actually start figuring out what else might be wrong. Also very important. What's going on? All right. And then there's a lot of enhancement. There's some monitors, or people are still playing around with the sharpness, what's called the sharpness control, peaking, not the peaking in the camera that actually shows you you're in focus. I mean peaking in the video signal. So they're increasing whatever, sharpness, detail, enhancement, whatever they call it, that actually gives you ringing, noise, and all that stuff you actually don't want to have in the signal. So they're adding stuff to it that should not be there. So with patterns, you can actually, with test patterns, you quickly figure out if the thing works right or the thing works wrong, right? Yeah, and then presets. People are using the wrong settings just because they don't know probably which setting they actually should use based in the color gamut and the color space they're working in. Like, am I working in 709 color, or am I working in P3 or 2020 color? So you want to make sure that you know what you're doing. So, how do we do this? Well, Calman software is exactly, for example, one of those tools that helps you to do this. So it's a de facto standard in Hollywood. Almost every studio is using it. And it's also a very versatile product because it actually talks to all the generators, all the meters, a lot of stuff, and of course, the monitors. It's also the mostly wide used in broadcasting, for example, so everywhere. The important thing is it's easy to use, and that's why so many people like to use it. And because it gives you also a way to verify your products. It also gives you verification and reporting. So you can create a report after calibration and you can see, oh, that was before calibration, now this is after calibration, right? And then it gives you trust. It's very good that the DP comes in for a grading session, sits down and knows when was this monitor lastly calibrated. Oh, that was like 2 days ago? Great, good. Oh, that was like a year ago? You probably want to calibrate this first before we actually start moving on, right? So you actually took, that's just a screenshot, pre-calibration capture. You see before calibration, it was just one monitor we measure, one display, TV. You see way too blue and all the delta is way going through the roof. Like I said, a delta of 2 should be, there's 27 because it just goes through the roof, way too blue. The gamma curve is wrong, everything is screwed up. And you see also here, the color saturation is wrong. It should be somewhere in the squares. So it's a wide gamut and it should be a small gamut. So you know, oh yeah, something is wrong. So you fix this after calibration, it looks more like this. So you have very nice grayscale linearity. All your color points are right? Very low delta of 1 in the color, a delta of 1 in the grayscale. The gamma curve tracks pretty well. It's a 2.4 gamma, 1886 as a standard. So that's how it's supposed to look like, right? Now, there are different versions of Calman, and it's more like, and then I'll move on with this. So there are different versions, especially one for studio. That's the one normally that's used in most of the studios because it also talks to a lot of hardware. I will get there in a moment. Like the ASUS monitor, the PA32DC, the new OLED, is a Calman ready monitor. So you can talk with our software to the monitor and calibrate the monitor. So it gives you a very easy, quick calibration. And you can use the same tool on camera monitors. You can use the same tool on your client monitors. You can always use Calman for everything. That's why people like it, because it fits into every single area of your production workflow. And then there's, as I said, Calman Ready. And that's exactly the reason why we are so happy to work with ASUS, because ASUS is actually making use of Calman DNA in 2 different kinds. One is the Calman Ready monitors that directly talk to our software for calibration. But what they also have is what they call Calman verified displays. These are displays that are pre-calibrated in the factory. So that means that we have already certified that in a specific way, that specific colors, the color gamut is meeting specific specifications, that you can trust that display in a much better way than if it would not be kind of pre-certified. And so that's the difference between Calman verified and Calman ready. And for example, the Calman verified specification is that the display should have an average of delta E, the delta of 2 or smaller than 2. A very important thing. So you know that at least when you look at this thing, it is somehow what it's supposed to be, right? That's one of the things. Also, the maximum should not be larger than 4. So there's some peaks depending on what kind of panel gamut you have, depending on what the panel can do or what the panel limitations are. So there are specific things we actually have defined for the primary colors, we have defined for the grayscale, and those kind of things. So just to give you a little bit more peace of mind, right? And here you see that's the delta E scale, right? And so after calibration, it should be somehow about 2 or smaller. And that's what they tried to achieve already in the factory process. Calman Radio, on the other hand, then, is actually talking to the display. So it takes out all that complexity of calibration. So it means that in the end, it's taking over the work, it's calibrating the display in auto calibration, it's loading a 1D LUT and it's loading a 3D LUT, like in the DC, in the PA32 DC, we load a 1D LUT and a 3D LUT, matrix LUT in this case, and we also can change a couple of things so that you really make it work the way it's supposed to work, right? And it's fully automated. So the software talks to the display, and we can even use the internal pattern generator. So the PA32 DC has an internal pattern generator. So you don't even need a hardware generator. If you don't want to have a hardware generator, our software can then create the patterns within the monitor. And then you take the readings and you calibrate the display. It's also pretty neat, actually. So the PA32 DC then is kind of a reference type OLED display. So it's made for colorists, or it's made for DITs on set. It's actually, and VFX people who actually want to have a high-end monitor they can somehow trust. That's a very important thing. So it's kind of, has even its own software. It has a built-in meter as well. So if you would not want to use one of our meters, you could even use the built-in meter. So, and it also has its own calibration software, by the way. So why would you still want to use Calman? Well, I told you, because most studios have Calman already, and they do all the other monitors as well with Calman. And so it's neat that this device, that display, also talks to Calman. That's one of the reasons. Another reason is if you have an OLED monitor in your environment, OLED monitors are very critical, especially when it comes to what we call observer metamerism. So every person sees color slightly differently. And especially with high saturated displays like OLED, you start to see the differences, everybody. So sometimes it's hard to match an OLED monitor within another setup of LCD screens. Maybe you want a perceptual match, or there are other reasons what you want to change. So it's somehow good to have different software that you can do this in the case you really have to do it, right? Yeah, that's how it looks like. And then there's a workflow. It's the ASUS monitor calibration workflow, and that guides you step by step through the process. So in the end, that was an HDR calibration. You see PQ curve is tracked very nicely. You see scale is perfect. It's a delta of 1. Average is 0.5. It's very nice. Color saturation points in the BT2020 gamut looks good. So that's what you want to achieve in the calibration process, right? Then there are other Calman ready monitors like the 32 UCG series, for example, or UCRK series, that are more for like game developers and content creation in general. So it's not that high expensive reference display, it's a little bit lower on the lineup, but it also has pretty much the same features and calibration capabilities. So you get this also under control and you know what your display is doing, right? It also comes with a meter. So there's an X-Rite i1 meter, and our software also talks to this. Since Calman talks to most all the meters, you can actually use that meter with our software as well. The monitors have that meter coming with it. I mean, I think it was the case. I hope I'm not over-promising here, I don't know. I think it was the case. And then we have the Calman verified part, right? So it's for photography, editing, all those other areas. Because maybe you don't want to do a calibration, or maybe not every artist needs to be a calibrator. The artist wants to be an artist. And I think the important thing is here that in specific areas, you probably say, well, in this case, we don't have to have top-notch technology because it's good enough for what we want to do, but we don't have to calibrate it necessarily all the time or do whatever we do with a high-end grading suite or whatever you do. So in this case, you have something that just gives you at least peace of mind that the display works very well when it comes out of the box, right? And we think a very important part here is all this distributed workforce. Now these days you have production somehow scattered across the world sometimes. After COVID, you saw that basically people started to work from home. And then you have the editors and you have those people somehow probably don't have a calibrator that can come into the home or into the office and then do that professional calibration. So you probably want to have a display you can trust, and it works in a distributed workforce environment, but at least you know that you can trust this thing. So if someone takes it, does some work on it, it goes back into contribution, then the next guy still can trust what you were doing because you still saw the correct colors, right? So that's where Calman verified displays actually come in very neatly. And then finally, there are other products too, like the StudioBook series has verified laptop monitor screens, right? So those screens are also pre-calibrated in the factory to meet specific color standards. That's also pretty neat, like if you're working with Resolve, not Resolve necessarily, but Premiere or Photoshop or whatever. So if you work with this and you want to have a specific color performance on your display, that's actually a good thing. And they have a projector as well. I think it was the world's first Calman verified projector. It's the A1. That actually can be used for 709, I think. In this case, it's BT709 color, so it's for HD. If you want to do more than that, you would need to, I think, use something else. But in this case, it has at least that kind of verification and make sure that you have something and you can trust there as well. So what's the summary? So it's actually from the lens to the big screen. So ProArt hardware, for example, gives you that confidence thanks to the Calman DNA, right? And from wherever you are, from on-set, near-set, on-camera side, contribution and post, finishing, delivery, and presentation somehow, there are a lot of different products that somehow fit into this category. And you can work with this, you can calibrate those, you can trust those, and you can work with it, right? To a specific point where it also is a neat price point compared to some other hardware which might be more expensive. At the end of my talk, I would like to invite you to have a look at our show. We have our own Hollywood show. It's called Color Matters. It's on our YouTube channel. It's 4 episodes which we produce with Photocam in Burbank, California. where Joseph Slomka, chief color scientist, and Alistair Arnold, the senior colorist who worked on the Green Knight, for example, Red Rocket, talk about how important color is and why you should take care of color in your entire production workflow. A very nice show. We're starting to produce season 2 this year. In May, we go to production. It's a very nice educational format. So I highly recommend that you want to have a look at this. And that's the end of my talk. So back to ASUS.
Okay.